It's a pleasure for me to be invited to give a lecture in the frame of the World Wood Days here in Stübingen. And the topic of today is I would like to give a status report from the CLT Hot Spot in Europe, Austria. And I would like to show you the content of my presentation. First, I would like to talk about timber at Graz University of Technology, some R&D topics, then a few facts and data about CLT. And then I like to show some selected sub and projects regarding the use of CLT, standardization work, and also what we are doing currently on different projects. And last but not least, I would like to make a summary on future prospects. First slide is on our university. So our university is located in the southern part of Austria, in Styria. It's the green heart of Austria with 61% of forest vegetation, so it's a lot. It's more than we have in Austria, in the Mean Valley. And when I talk about the University of Technology, we have to consider that we have 7 faculties at our university with approximately 14,000 students and a staff of 3,350. The current budget is in the range of 225 million euros. Our faculty of civil engineering and civil engineering sciences consists of 15 institutes with approximately 1,400 students, and one of these 15 institutes is my Institute of Timber Engineering and Wood Technology. This was founded as Chair for Timber Engineering in the year 91, and then in 2004 we became the status of an Institute of Timber Engineering and Wood Technology. Currently we have 8 scientists working on different topics on this field of civil timber engineering and wood technology. Furthermore, we have a competence center also located in our Building Research Center. It's called Holzbauforschungs GmbH, and this is a competence center which is organized together with the industry, with the Austrian industry, and also with the university. And this is normally based on funded programs, 4-year funded programs, and the last program is called Utopia, which was submitted end of January this year. The current staff is in the range of 5 to 6 scientists working also on different topics, mainly on applied science topics. Our research topics are divided in 4 different fields. So one field is on shell and spatial timber construction. Here we are mainly working on topics on CLT. You can see a few pictures, our desk configurations. And then we have also one very important topic called Innovative and Intelligent Connection Systems. Here we are mainly working on self-tapping screws. So this is a really also very effective timber connection system. The third topic is on lightweight and hybrid hardwood applications. Why? Because in future we will have more and more hardwood species which should be also used for the civil engineering sector. And here we are using veneers. So these are veneer-based products. We are able to press profiles, and this is, in my point of view, a very interesting topic for the future use of hardwood species. And the fourth field is on evaluation and maintenance of historical structure. This is the reason why Graz is a World Heritage since 1999, and that's the reason why we did, and we are also doing projects together with the government, the city government of Graz. Now let's talk about CLT. Few facts. The current Yes, I will explain it in one of the next slides. Yeah. So, CLT plants. So, CLT plants, currently we are talking about 60 plants worldwide. And 50 of these 60 plants are in process or in planning. So, and you can see also this focus of this hotspot here in Europe. The production, the CLT production amount is really fast increasing now. We had, in the early 90s, we had kind of a niche product, and then we had the market entry of KLH between 1995 and 2000. And one of the most important facts was the market entry of different producers in Austria between 2005 and 2010. For example, Stora Enso, Pinder Building Systems, and Meyer Melhoff, for example. And I think so currently we are in a status that we can talk about a mass product now. And you can see in 2018 we reached this 1 million cubic meter production amount, and sooner or later, I think so, we'll also reach this 1.25 million cubic meter production amount of CLT by the end of 2020. Now, what's happened in CLT regarding the production situation in Europe and worldwide? You can see this hot spot here in the German-speaking countries. The current situation is that we have 90% of the whole production is in Europe and 60% are in Austria. For us, important markets in the European community are Scandinavia, especially Sweden. We have a lot of activities there, also Finland and Norway. And, of course, UK and France. Important future market worldwide, here we can talk about Japan, USA and Canada. I was in Japan 2 weeks ago, and it was really impressive. They are really on a fast forward way to also implement CLT production lines there. And we are also in contact with Russian companies. Now let's talk about CLT, and here I would also explain the shortcut of CLT. Yeah? What is CLT? But first, let's talk about the standardization work. Why we need standardization work on cross-laminated timber. This is important because we have to consider a wider use of CLT products in our building sector. And the European community decided to have a chapter on CLT in a revised version of Eurocode 5 in the year 2022. And that was the reason why a project team was founded consisting of 6 colleagues, 2 from Austria, 2 from Norway, and 2 from Germany. And they prepared 2 documents, a standardization document and a background document. All in all, we are talking about 70 pages where we have all the explanation and also very important information for engineers and architects on CLT. So this is the content of the standardization document and the background document. The background document is very important because we have also to explain something, what's given the standard. So here we have 11 chapters from scope, normative references, terms, definitions, and symbols, basis of design, something about the material, durability, structural analysis, ultimate limit state design processes, serviceability limit state processes, and components and assemblies. The part of connections is worked out in another group. It's the team 5, and they are working on different connection systems, not only on CLT, but also on this topic. Now I would like to talk about 4 chapters, a bit in detail. I would like to talk about terms, definitions, and symbols, basis of design, material, and components, and assemblies. Now, here is the definition now. Terms, definitions, and symbols. What is CLT now? Cross-laminated timber is a structural timber consisting of at least 3 face-bonded layers which comprise solid timber laminations and may comprise wood-based panels, at least 1 layer orthogonally oriented to the 2 adjacent layers. What we can see here is the wide face, the narrow face, and we have also outer layers and inner layers. So, what is important for the engineer? For the engineer, we have 1 chapter which is called Basis of Design. And this is something for the engineers now, but I think so it's really important to know this. We have to consider a safety partial factor in the European standard called gamma M for CLT, which is in analogy to GLT, and we choose this factor with 1.25. And then we have something for regarding the materials, and here we have to consider for the ultimate limit strength design also the load duration and moisture influences on our product. And we are using this K-mod factor. It's the modification factor, which is really also very important. And this is also in analogy to glute-laminated timber. Yeah? And we consider service classes and duration of load classes. And you can see for medium-term and short-term loading classes, we have a factor between 0.8 and 0.9, which is a modification factor and a reduction factor of strength values. And then we have also to consider the low duration and the moisture influences on the deformation. It's a surface limited state process. And here we have the K-def factor. And the K-def factor is in line with plywood. Of course, this is also, I think so, we can understand it because plywood is also a product where we have orthogonal layers. So in the deflection is more or less similar to CLT because in the US or in Canada, very often CLT is named as jumbo plywood. Yeah? But that's really interesting wording. And here we have this deformation factor also considering or depending on service class 1 and 2 and 3. And here we have factors between 0.8 and 1.0, which means this is the deflection based on creep. So, and now some words to materials. And when we talk about materials, so we have to consider a strength class system. And this is, was very long and open question for CLT. And in the new standard, you will find all the characteristic values in a very important table of strength and stiffness values. You can see it here. I'm not able and I'm not willing to explain all these values in detail, but I would like to focus on the bending strength. Yeah? This is the most important characteristic value when we are talking about the strength class, because the definition of a strength class is given here. We are called our strength class system in Europe CL24, and CL means cross-laminated, and 24 means the bending strength out of plane. And how can we get this information? So we have to do bending tests on our reference cross-section, and the reference cross-section is given here with a width of 600 millimeter in minimum 4 laminations parallel acting, and with a height of 5 times the reference thickness of 1 lamination. So this is the reference cross-section, and if we like to know something about the capacity of a panel, we have to do this test on this reference cross-section. The other possibility is to use a load-bearing model. This is very common in different product standards. And this load-bearing model is very simple, in principle very simple, because it is based on the tensile strength of the port with an exponent of 0.8 multiplied by a prefactor ACL. And this factor ACL, of course, depends on different K factors. I cannot go in detail now because lack of time, but when you have if you look to this column here, you can see there is a value, there is the formulation 3 times the tensile strength with an exponent of 0.8 is also one possibility to get the strength, the bending strength of your panel. So you can do tests, or we can do it with this load-bearing model. Now, I would only focus on one component and assembly element, because this is, in my point of view, one of the most important elements, which is currently also on our table, because we have to do also research, further research on this kind of hybrid element. It's a so-called ribbed blade built up from cross-laminated timber. This is the cross-laminated timber element, and also combined with ribs. And these ribs are normally glue-laminated timber. What we have to consider for the calculation process is an effective width, and this effective width depends on the rib, on the width of the rib, and the effective width on both sides of this rib. So, and you can calculate this formulation based on the on this chapter 11, where you can find all the details or further details how to get this P effective values. So, how is this so? Why is this so important for us? Because there is one very important fact. Currently, we are looking for a wider use of different systems, and one very important fact is we have to have longer spans for our systems. And when we are talking about longer span, then we are talking about spans from 8 meter up to 15 meter and more. This, for example, shows you an idea, or gives you an idea of a ribbed blade. And this ribbed blade is, for example, this is a an application which was used for the roof system in our Building Research Center. Now, I would like to talk about another topic which is, in my point of view, a future topic. It's called Prefab Modules. For me, it's one very good possibility to use such modules for densification processes in our cities. Prefab modules are prefabricated room cells or shelters based on CLT. And when we have this kind of models, or when like to work with these models, we have to have a standardized measurement called module, and then you can multiply it with a number. For example, if this module, this fixed measurement is 3 meters, perhaps you can say that we have a volume 3 by 3 by 3 meters, and this, for example, it's possible to call this a small module with different length, and then we have 2 times this measurement. We can have 6 meters, or 3 times this measurement of 3 meters. We have 9 meters in length. So, and then we can also decide to take a short, to take this possible steps, and we can call it small, medium, or large. And the second is we have to consider different types of modules, and here we have modules which we can different by their position. And here we have, for example, one room where we have 2 edge modules here, and 2 middle modules here. And all in all, if we combine these modules, we can have at the end a very interesting room configuration. Another type of module, so we have types according to their structure. And here we are talking about closed on all sides, or closed modules on all sides, open on 1 side, open on 2 sides, 3 sides, and 4 sides. And we have also the possibility to use single modules and multi-modules. So a single module is usually have this sanitary unit which is integrated in this module, and it's suitable for hotels, for nursing homes, and student residences. And the combination of single modules, which is given here, results in multi-modules which can be used for school buildings. An example, here you can see this is an edge module, a middle module, and an edge module. And if this length is 9 meters and this width is 3 meters for each of this module, you have more than 80 square meters for this classroom. And this is very common in Europe to use this kind of classrooms now. Now, I would like to give you an overview regarding the realized projects in the German-speaking countries. So we have hotels, schools, and kindergartens, residential office buildings, and also care home or student residences. I've only considered here two companies working on this kind of modularization. And you see this developing process between 2008 and 2012. This was the starting point here in Austria and also in Germany. And between 2013 and 2015, we had a lot more of these systems used for different projects. And all in all, we have also something in construction. But we can see there is a strong increasing factor by using this prefabrication between 2008 and 2012. This was the starting point here in Austria and also in Germany. And between 2013 and 2015, we had a lot more of these systems used for different projects. And all in all, we have also something in construction, but we can see there is a strong increasing factor by using this prefabrication modularization concept in the building sector. So now I would like to go a bit more in detail. You can see now here realized projects. 2 hotels in Austria and 2 hotels here in Germany. This is, for example, the assembling process during the erection time. You can see this prefabricated model. Here you can see the prefabrication in the factory, also here, which is more or less finalized, and here the finalized concept for Ludwigsburg. And at the end, these are the final projects. You can see this is a very intelligent use of modularization, and at the end you can also see very interesting architectural concepts. Have a look on these floor plans, the ground floor plan, and here you can see, for example, in case of Ammerwald, we have 5 stories there, and 3 stories are built in this modular design, where we have 4 different types of models, and in total 60 models were used for this concept. You can see these 4 different models, the blue one here, the red one, orange colored ones here. For Ludwigsburg, we had 5 stories, and 4 stories are built in modular design, and 5 types of models were used, and in total we have 48 models. But what is the problem? And here we have also one very interesting project, which is an ongoing project together with a company in Austria. It's called SenseGD, which means sensor-secured building systems. Why is this so important? We have analyzed different projects, and you can see there are so many differences regarding the MAP system, mechanical, electrical, and plumbing systems, and bathroom layouts. And this is really a bit dangerous. Why? Because there are different types of regarding the location of the shaft. There are different lengths regarding the pipes, the water-filled pipes, and because perhaps if there are leakages, that could be a really big problem for water ingress inside the building. And the main objective of the project, to have, on one hand, a reduction of the numbers of different MAP systems, and also we like to reduce the pipe length. And of course, we like to optimize the system, and at the end also we are currently working on sensor-secured building systems. So at the end, or the idea is to reduce our MAP system or bathroom layout to 1 for each category of building, perhaps 2. But you can see one example. It's a very short pipe length to the shaft, and this can be used, for example, for different kind of hotels. So this is one opportunity, and in my point of view, a very important fact in the future, using CLT for this kind of projects. Now let's have a look on this production situation. This is the production line of Kaufmann in Kalban. This is a brand new factory where we have 6 production fields for screed work, you can see it here, and 20 for module assembling processes. So we are able to also implement building services at the plant. So this is a very good opportunity. And the production amount is in the range of 6 modules per day, and the production per year is currently on 2,200 modules per shift, and the capacity is in the range of 2,400 modules if there are 2 shifts. And the production line started in February this year. Now I would like to finish with one very interesting project now. It's called CLT Follows Form for freeform surfaces. And here I would like to talk about the project House of Bread. It's a museum concerning the history of bread. You can see the company is Kornspitz Company, and the owner of this company, this was his dream to have his own museum. This is also located very near to his factory. And the customer's request was this kind of a museum. And this was the first idea of an architect, very famous architect, Bob Himmelblau, Wolf de Brix from Vienna. And you can see this shape looked like these 2 breads, which was shown before. Or you can also see a cloud. And at the next, you can see the cross-section of this structure. So the first floor is a concrete floor with the entrance room and the shops. And the other 2 stories are fully built in CLT. So, and this is the cross-section now. This is the engineer's plan now, and you can see the decision was to use a composition of layers in CLT, and the joining between the layers was done by screw press gluing. And the reinforcement was done by self-tapping screws. You can see the combination of CLT and innovative connection systems like self-tapping screws. So the maximum height was 10.6 meter approximately, and the maximum length, 26.5 meter. So we did, or there was, the calculation was done by an office located in Upper Austria. They did a simplified model applying a beam statics, and we had then the we had to do this validation by a 3D volume finite element analysis, and at the end we confirmed that both results were in the similar level. And you can see this is there are stresses, a peak of stresses here in this outer area of the building. But all in all, we can say the strength or the stress in this building was very low. And then we decided to give the okay to build the building. And you can see the production now. For the production, we used a CLT raw material of 600 cubic meter with 3, 5, 7 layered CLT elements. You can see these stapled elements here. Then we milled this cross-section to get the final shape on the outside and the inside of the building. And at the end, we had a final structure with 400 cubic meter, consisting of 80 rings with a total height of this 10.6 meter. And the width was only 40 centimeter for the whole building. And now some words to the assembling processes. And this was done by the application of adhesive. You see this red colored line. And then we used CLT elements. We had to position these elements in the correct place. And then we had this screw press gluing to get the pressure between the layers, layer 1 and 2. Here is the glue line. And then we had these load-carrying screws, which are important for these normal stresses. And then we did it again and again and again. And at the end, we used in totally 120,000 screws. So the producer of screws were really happy with our project. But here you can see this assembling process on site. You see these screws which were used for this screw press gluing. And you see this final product. I think it's a really fantastic shape. It's a free-form shape done by CLT. And if you go inside the building, it's a very nice shape. You can see this CLT layers, very good. And I can recommend you to visit this museum. It's really fine, it's really nice museum. Now, short summary and future prospects. Now, we have seen that the application possibilities are really different. So we can use CLT for 1D and 2D elements, but also as a 3D model and even also free-form surfaces. So this, for example, gives you an idea of beam and columns. So it could be also in CLT. Then we have these two-dimensional wall and ceiling elements. And of course, I have also shown something about these 3D models. And but last but not least, we are also able to define free-form surfaces. What are our new projects? So our new research or ongoing projects are on GLD, CLD ripped plates. So we need these systems for the application for larger spans. And here we have to optimize the bonding pressure applied by self-tapping screws. So this is really important to have an optimized bonding pressure. Otherwise, at the end, we're not successful by using these self-tapping screws. And then we have to define suitable adhesives and also screw spacings. This will be transferred by a PhD and also in case of an interpaper 2019. The next project is also, in my point of view, an important project because we have always to do something with stiffness, so we have to do stiffness grading. We always talk about stress grading, so for us it's important to have a stiffness grading process to increase the performance of CLT. And here we are looking on different wood species in future. For us, Douglas fir would play an important role in future, and also birch and poplar. And this gives us a positive effect on the serviceability limit state verification processes, as higher stiffness is important regarding deflection and vibrations. And now, last but not least, my last slide is on this project is Utopia. So why Utopia? It's utopian to use wood in the city, but we should try it. We should use timber in our cities. And we submitted a European project together with 27 partners from 7 nations, 10 from the research sector, 14 from the industry, and also 3 networks. And the idea is to have this Utopia infinite loop, which means we are going from the forest, it's the rural loop, then we are coming to the model loop, and then the final loop is the urban loop, and then we start again. So it's an infinite loop. We have to do it again and again and again, and we have to reuse, and we have also to redefine these products again, and we have also to consider the rural area in our European community worldwide. So it's my point of view very important. It's not, we shouldn't allow only to consider our urban developments. We have to consider also our rural regions. And this is, in my point of view, a very good, gives you a very short introduction in these projects. The objective is to industrialize the often on-site building with food processes, and a main or a significant role will play prefabrication, modularization, and standardization work. So, thank you very much.